Good day, everyone. I am Jason T. the OHOP, and we're gonna present the input-output organization. So, first, let's introduce input-output. Input-output provides an efficient communication link between the central system and the outside environment, meaning no na it basically handles all communication between input and output. So, let's say, for example, we have peripheral devices, no? Like kabantay man mo ano to ang keyboard and mouse, no, pag dili man na siya directly gina-connect sa ato ang computer system, no, like mukalit na kita na outside kanang kuha na siya kanang external na siya, and basically dili na siya diretso, like pag connect na to dili na siya diretso sa ato kay kung sa ato na part kay diretso man na siya, pero naay ko na naay handle na which is ang input output. So it basically also manages the data transfer between the CPU, memory, and the peripheral devices. So input-output organization varies based on the size and type of the computer and the number and nature of the input-output devices connected. So may balaan na nato na siya unya ano dili pwede ta mo direct o connect sa ato ang mga peripheral devices, no? So sa ato ang input-output na ginatawag na module interfaces, and which with each IO module interfaces, it has a system bus or central switch. It controls one or more peripheral devices and contains logic for communication between peripherals and the system bus, not just connectors. So here are the mga reasons why na ato ang peripherals are not connected directly to the system bus or sa ato ang computer, no. First is the variety of devices. Peripherals differ greatly in function and control methods. So basically no na ang ato ang, for example, natay keyboard, mouse, printer, no, muna mga tawag mo nato na sila peripheral, although different sila, no. Natay ginatawag na input, natay ginatawag na output, peripheral sa natay input, mamaya na yan. So lain-lain sila function, no, lain-lain sila og kanang saan pag-control, and then naputay ginatawag na speed mismatch. So sometimes no na ato ang mga peripherals na device na i-connect is kanang masinay siya kaysa atong computer, kaya atong computer mas paspas biya. So dili siya mag-vary siya pagkuan, dayon pwede pod na ang ato ang peripherals is mas connect sa atong system, no, sa atong system na gihandle, so di pod na pwede. And then naputay data format differences, which often na ang ato ang peripherals uses a different data formats or word lengths sa CPU. Sa atong speed mismatch, no, kay ma-remember ninyo na term ang handshaking, no, kay to ang handshaking magpamurag ikon bitaw niya kwan bitaw niya murag ikon niya ang speed sa peripheral device ug sa to ang kwan ba sa to ang computer, so magkakuan sila, magkatugma, no. So why an IO module is needed, no? So it is to manage communication between the processor, memory, and peripheral devices effectively. So it basically an interface to the processor and memory via the system bus or central switch, and it also interfaces to one or more peripheral devices by tailored data links. So muna iyahang iyahang diagram. So peripheral devices, no, so peripheral devices are just external devices connected to a computer to exchange data with external environment. Ang ginaingon kanina, no. So natay ga-enable na siya input and also has output. It also communicates with the CPU and memory through commands and signal conversions. So we have categories of peripheral devices, no. First is the human readable devices, suitable for communicating with the computer user, no. So natay printer, naputay video display terminals. We also have machine readable devices. It is suitable for communicating with equipment. So example are sensors, actuators, no. So apply din siya sa robotics. And also lastly, we have communication devices. It allows us a computer to exchange data with a remote device which may be a human readable device such as terminal. So kung mag-SSH na no, from sa example sa akong laptop, then i-SSH na akong computer no. So gagamit na ko na communication device. All gamit lang nako is terminal. Or even no, like sa gingan din na other computer which is ako ang example ganina. So, peripheral devices are components connected internally or externally to a computer. They enable data transfer such as entering, displaying information. They are part of total computer system, often functioning as electromechanical or electromagnetic devices. So, we have three types of peripherals. No? First is the input peripherals. Familiar kay taan eh? So, it allows user input no? From the outside world to the computer. So, ato ang keyboard, mouse, so others na pwede ta maka-input no? Like for example kanang volume controller kanang naman ay sa tawag sa term na basta kanang ga control with volume. Then we also have output peripherals, so allows information output no, so from the computer to the outside world, so mas mabasa na to siya, mas masabdan na to siya. For example, printer. So, gina-output niya ato ang gusto ipa-print and then napot tayo monitor. Also, we also have input-output peripherals, no? So, it allows both, no, input or output. So, great example lang eh, kaya ato ang touchscreen, no? Touchscreen provides output, no, information, makita na to. Then, we can also maka-input punta sa ato ang touchscreen, no? So that is all for the peripheral devices.
On the next section, we'll be focusing on the different data transfer schemes that computer use to move information. So data transfer happens between any of these combinations. First is the CPU and the memory. Next is the CPU and input-out devices. And lastly, memory and input-output devices. So the problem is that the computer interfaces with many devices of different speeds. So a hard drive, for example, is much slower than the CPU. And because of this, input-output devices may not be ready to transfer data as soon as the microprocessor issues the instruction. So data transfer schemes provide an efficient means for transmitting data between the fast processing unit and the slower input-out devices. So as you can see, these schemes fall into two broad categories. First is the program data transfer, where data is in charge, and direct memory access, or DMA, a special controller takes place. So in program data transfer scheme, data transfer takes place between CPU and input-out devices under the control of the program that it is executed by the CPU. So this means that CPU is involved in every step of the process, and because of this scheme is mainly used when a small amount of data is to be transferred. It would be very inefficient for large files. There are three main types of program input-output. So first we have is synchronous data transfer. So in this method is used when the processor and the input-output devices match in speed. So because they're operating in sync, they can use a common clock cycle to coordinate the transfer, and this allows the data to be sent as a continuous stream, which is very efficient because there's no need for extra control bits for every single byte, and the overhead is very low. Next is asynchronous data transfer. This is applied when the speed of input-output devices and the microprocessor do not match, and when the device timing is unpredictable. So since there's no shared clock, it relies on the handshaking process where each byte of data is framed with start and stop bits. So this tells the receiving device exactly when a piece of data begins and ends, ensuring a reliable transfer even with speed difference. And lastly, we have interrupt-driven data transfers. So in interrupt-driven data transfer, the processor enables the input-output devices and then continues to execute its original program instead of wasting time on checking the status of the input-output devices. So the CPU issues a command and moves on. When the input-output device is finally ready, it sends a signal called an interrupt to the processor. The CPU then processes what it's doing to handle the data transfer and then resumes to its original tasks. So this avoids having the CPU sit idle just waiting. And for the next category is direct memory access, which is used when there is a need to transfer bulk data. So for large transfers involved in the CPU is too slow. So in DMA transfer, data is directly transferred from the memory to the input-output device or vice versa without going through the microprocessor. So this is a hardware control technique. So a special module called a DMA controller is just what manages the transfer. So the CPU just sets up the transfer, telling the controller what data move and where, and is then free to perform other tasks. The DMA controller needs to access to the system bus to move data, but the CPU also needs it. So to manage this, the DMA involves the additional module, the system bus, that is capable of taking control over the system from the processor. So the most common technique for this is to refer to cycle stealing. So essentially, the DMA controller momentarily forces the processor to suspend its operation. So the DMA module in effect steals the bus cycle from the CPU to transfer piece of data. So after that, the transfer then returns the control to the CPU. So this happens very quickly and minimizes the disruption to the processor's work, making it very efficient method for high-speed data transfers.
So good day everyone. Let's talk about input-output interfaces. So when we say input-output interfaces, there are two types of interfaces, with the CPU interface and the input-output interface. So the concept of interface is that it's shared boundary between separate components of the computer system, which can be used to attach two or more components to the system. So meaning, for example, siya og extension, kumbaga, kung if we connect one into interface, then pwede po na to siya connect sa other nga component. So input-output interface. So in input-output interface, it helps us understand how devices intercommunicate. And all the peripherals nga na-connected sa isa ka computer require special communication for interfacing para maka-communicate sila sa CPU. So, in short, tanan peripherals is naa siya input-output interface. So the importance of communication connection is to resolve differences that occur between the computer and each of the peripheral. So the major differences are, first, the peripherals operate differently from the CPU and memory, so signal conversion may be needed. So peripherals also transfers data slower than the CPU, so need siya og synchronization para pagtuplok nimo sa keyboard or mo respond siya on time, no. So peripheral data formats differ from the CPU and memory word format. And then each peripheral has different operating modes, so that must be controlled to avoid interference. So connection of input-output bus to input-output devices. So input-output interface units is a special hardware that supervises and synchronizes all input-output transfers. So as you can see here in the diagram, each interface, each peripherals has its own interface to be able, so that the peripherals can communicate to the processor. So kita ninyo, example kaning keyboard, niagi siya una sa interface, then sa interface na connect sa processor, which is also connected specifically to the control, address, and the data. The same with the printer, magnetic disk, and magnetic tape. And then the input-output interface provides communication links between processor bus and the peripherals. So in this way, they provide a method for transferring information between internal system and the output devices. So in this way, with the help of these input-output interface units, the internal, which is the processors, and the peripherals, which is the outputs, are the input and output, which is the peripherals, nasa like communication, and they exchange data and information with the help of input-output interface units. So next is that, for example, kani si printer. Again, printer can perform actions such as control of paper motion, print timing, and selection of printing characters. It's because that the input-output interface unit supervises the transfer of data between peripherals and the processor also, which is synchronizes the data flow. So mo nang si printer maka perform siya ani nga mga actions. So next is the input-output commands. So there are 4 input-output commands, which is the control, status, data output, data input, and yeah. So when we say I/O bus, it's the pathway used for peripheral device to communicate with the computer processor. So si input-output bus kay ayar siya ma-activate if ma-detect na to siya nga address. So kung ma-detect na to nga address, kana nga interface, ma-activate din to nga path between bus lines and the device that it controls. So katong nasa chart kanina, ay sa diagram kanina. So input-output bus is connected to all peripheral interfaces para maka-communicate sa processor. So siya ang dalan gikan sa interface to processor. So the processor place a device address on the address line to communicate with the particular devices. So mao to siyang nasa chart ganina ay sa diagram ganina, no. So input output command. So first is the control. The control command is activates the peripherals and assign its task based on specific operating mode. So basically siya ang mag-control kung unsa ang siya ang unsa nga operating mode ang need niya i-activate para sa specific na task. For example, kaning magnetic tape may be given instruction to rewind the tape by 1 record. So to rewind the whole tape or to start the tape moving in the forward direction. So meaning need niya nga i-set yung operating mode with a given instruction. For example, kanito rewind a tape by 1 record. So need niya move forward sa una ma-play forward ang katong tape for it to rewind, no, para ma-rewind to niya ang ihang na forward niya nga tape. So next is the status command. A status command is used to test different test conditions in interface and the peripherals. So when we say status command, mabala na to kung say status sa process. So for example, a computer may require checking the status of peripheral before a transfer is made. So during the transfer, the errors that occurs are detected by the interface. So these errors are cleared by setting bits in the status registers that processor can read at certain intervals. So in these cases, kanang na mga error no sa atong mga peripherals dili wala ga communicate og tarong ang processor o ang ato ang mga peripherals. Next is the data output. Data output command makes the interface respond to the command by transferring data from the bus of one of its registers. So may tag data output, basically kanang mag-input ta og data kanang sample from peripheral to processor. Kung for example keyboard nag-type ko, so na mo to siya ay for example ang sa output for example sa output sa monitor, so nanigawas na display. So it's the respond sa command nga gihatag or gikan sa processor. So for example, in a tape unit, when a control command is issued, so naay task nga gi-activate, so in an operating mode gi-activate, so the computer starts to tape the tape to move. So murag siya ang outcome. So may output outcome sa input murag inana. So next is the data input. So the data input is the opposite of the output no command. So it allows the interface to receive data. So ang consequence ani is peripheral to processor. So for example, mag-input magtuplok ta sa keyboard. Dayon ang kaning data gikan sa keyboard padulong sa processor, mao na siya ang data input. So meaning nagtuplok og J, dapat ang output mo gawas. So pagtuplok og J, ang data from keyboard to processor yang i-process, tapos yan ang i-output nga J ang gituplok. So aya din mo activate ang bus, IO bus, kung na-detect niya ang address in that specific peripheral. Aya ra siya ma-activate kay pathway man siya. So next is the IO bus and the memory bus. So mayong tag memory bus, it contains an independent set of data, address, and control lines. So in simple terms ani, kay both IO bus and memory bus must communicate with the processor for it able to communicate sa processor o sa peripheral. So mo ni ang three ways for buses to communicate with the memory and input output. So first is that it uses two separate buses, one for memory and other for IO input output, and the control structure use one common bus for both memory and input output, but separate control line for each, and use one common bus for memory and input output with common control line. So nani gid siya, no? So both IO bus and memory bus yun ang dapat mag-communicate. So that's all.
Next is the input-output channels and processors. So the evolution of the input-output function. So as computer system evolved, the input-output function became more complex and independent. So the CPU is no longer the only component managing input-output operations. So the special modules and processors handles this task efficiently. So the 6 evolution steps of how the input-output function has improved over time. So first is the CPU directly controls peripheral devices. So in the earliest computers, the CPU had to handle everything, including input-output. So this was simple but inefficient, as the computer had to wait for the device to finish every task. Next is the controller or input-output module is added, like programmed I/O. So the system added input-output modules. So these modules handles the details of communication with devices. So the CPU didn't need to know every small signal or timing details. Next is the interrupts are added to improve efficiency. So with interrupts, the CPU could do other things with only respond when the device signaled it was ready, making the process much faster. Next is that direct memory access is introduced. So the input-output module could now directly read or write data to memory without CPU needs, freeing up the processor for other tasks. Next is the input-output module becomes processor. So the input-output module was enhanced with its own instruction set, meaning it could follow input-output programs stored in memory. So that CPU just tells it what to do and doesn't have to monitor every step. Lastly is the input-output module gains its own local memory. So, and lastly is the input-output module evolved into a full input-output processor with its own local memory and logic, capable of controlling many devices independently. So in short, as we move through each step, the CPU does less of the input-output work and the system becomes more efficient and faster. Next is the step 1 to step 3 basic input-output handling. So, in the early steps, kamantay mo itong last na ko patang previous na ko ang giingon, the CPU had to do everything. It directly sent and received data from devices. But that was, gabit ko siya kahinday, di siya to efficient nga gamiton to siya nga mga steps. And so input-output module was introduced para mag-help. So then interrupt allowed the CPU to do other work while waiting for input-output operations, making the system more efficient. So step 4 to step 6, DMA and input-output processors. So as the systems advance, the input-output module could directly access memory. That's DMA. So it became smart enough to act as a mini processor capable of running its own input-output programs. And lastly, it became an input-output processor with its own memory capable of controlling many devices independently. So CPU and I/O relationship. In the last two stages atong step sa step 1 ay step 5 and 6, the CPU does less and less input-output work. So it only gives high-level commands while the input-output processor takes care of the details. So this separation improves performance and allows computers to handle more devices efficiently. While ga-evolve ang computer is kanang mas efficient na siya gamiton and mas faster na gid siya. So, input-output channel ang yung definition. So, an input-output channel is like a smart manager for input-output operations. Instead of the CPU doing everything, the input-output channel takes over. It runs on its own input-output instructions, controls data transfer, and just tells the CPU when it's done or if an error happens. So, this makes the system faster and more organized. So, channel processor are simple processor dedicated to input-output work. So the CPU prepares a list of commands, give it to the channels, and the channels finish all the operations. So the CPU is only interrupted when everything's done or if there's an error. So the IBM 370 input-output channel. So in the IBM 370, the input-output channel concept was used effectively. Each channel acted as an independent processor, managing several devices. So this became a model of our mini-future computer system. So there are three main categories of input-output channels, and each one has a different way of handling devices. Number one is the selector channel. So the selector channel is designed for high-speed devices, meaning it focuses on transferring large amount of data quickly, but only from one device at a time. So next is the multiplexer channel. So on the other hand, it is used for several slower or medium-speed devices that can share the channel at the same time. And lastly is the block multiplexer channel. So this channel combines both of these features. It can manage multiple devices like the multiplexer, but it also supports high-speed operations like the selector. So these types of channels were made so computers can handle many devices efficiently depending on their speed and purpose. So the selector channel. So the selector channel is a type of input-output channel that connects the CPU to one device at a time. So it is called a selector because it selects just one device for data transfer and focuses entirely on it until the operation is finished. So this type is perfectly for high-speed device like disk drives or magnetic tapes that need quickly and direct data transfer without interruption. So the channel itself takes over some of the CPU's work. It controls the input-output controller directly, freeing up the CPU to do other processing tasks. So in the image, you can see how the selector channel links the CPU to a single input-output controller. So once the CPU starts the process, the selector channel manages the entire data transfer independently. Next is the multiplexer channel. So the multiplexer channel is designed to handle several input-output devices at the same time. So especially those that works at slower or medium speed. Unlike the selector channel that focuses on one devices, this one can share its time between multiple devices by dividing its data transfer into smaller parts. It uses method called byte multiplexing where small amounts of data from different devices are transferred alternately, almost like switching between them very fast. So this allows the computer to communicate with printers, terminals, or other slower peripherals all at once, keeping the CPU free from managing each one individually. So in the diagram, you'll notice the multiple controllers are controlled. So multiple controllers are connected to one multiplexer channel, showing how it handles many devices together efficiently. Next is the block multiplexer channel. So the block multiplexer channel is a more advanced version that combines the strength of both selector and multiplexer channel. It can handle multiple devices at once like a multiplexer, but it also manages large high-speed data transfers like a selector channel. This channel works by interleaving blocks of data, meaning it can transfer chunks of data from different devices one after another without waiting for one to completely finish. So the CPU can also communicate directly with these channels through control lines, giving it better coordination and faster control over input-output operations. So in simple word, this channel type gives the best of both worlds: efficiency for multiple devices and high performance for faster transfer. Next is the input-output processor. So the input-output processor, or IOP, is like an upgraded version of an input-output channel because it doesn't just move data. It also has its own processor. That means nga it can execute instructions for a input-output task directly without always waiting for the CPU. So when the system needs an input-output transfer, the CPU gives a command to the input-output processor, which then follows the program in memory that tells it what to do, which memory area to use, and how to handle certain situations. So basically, the input-output processor handles input-output works more intelligently and independently. So there are the features of input-output processors. So the input-output processors can fetch and execute its own instructions. The input-output processor can read and runs its own setup of instructions stored in memory without the CPU's help. This makes it capable of managing input-output operations independently while the CPU focuses on other tasks. It has instructions especially designed for input-output processing. So the input-output processor uses special instructions created specifically for handling input and output operations. So these commands allow faster communication and control between devices and memory. Number 3 is this. It can perform arithmetic and logic operations as well as branches, searches, and translations. So aside from transferring data, the input-output processor can perform simple math comparisons and conditional actions. It can also search for data or convert it between different formats when needed. Next is it performs all tasks related to input-output transfers, including device setup, program input-output, and DMA operation. So the input-output processor is responsible for setting up devices and managing data transfer automatically. It can handle program input-output and DMA operations without the CPU constantly supervising it. Next is it can transfer data between devices with different word size, like example 8-bit, 16-bit. So the input-output processor can move data between devices that uses different data sizes or formats. So this makes it flexible when connecting old and new devices together. Next is the it uses memory-based control block to communicate with the CPU. So the input-output processor and CPU can exchange information through control blocks stored in memory. So these blocks control data like input-output instructions, status, and control information. And lastly is it supports a multi-processing environment allowing both CPU and input-output processor to work simultaneously. So both CPU and input-output processor can operate at the same time without waiting for each other. So this parallel processing improves the overall speed and efficiency of the computer system. That's all po. Thank you.